Ohm's law states that the voltage is the current multiplied by the resistance. Rearranging the equation means that the current is the voltage divided by the resistance. If algebra is not your thing, here's something I first saw in, I believe, a Heathkit manual. Place your finger over the value you want, and the resulting sections will show how to calculate the desired value. So, in order to use Ohm's law, we need to know the actual resistance of the resistor. It's 5.338 meg. Now we need to know the voltage coming from the power supply. To measure voltage, the meter is placed in parallel with the part being measured. In this case, the power supply, resistor, and meter are all in parallel. It's 4.964 volts. Ohm's law indicates the current should be 0.9299 microamps. Let's see if it is. To measure current, the meter must be in series. I purposely set the meter to a high current setting to show that if you don't know how much current is in the circuit, it's a good idea to start at the high current jack and range. If the value is too small for that setting, it would be safe to go to the lower range. It's also a good idea to get in the habit of returning the red test lead to the voltage testing jack when finished with the meter, so you won't accidentally blow the meter the next time you use it because you didn't realize it was in the amps milliamps current testing jack. In this case, we know the current is low, and that's why in this setting the meter reads 0. Switching to the microamps setting now shows the current is 0.92 microamps. By the way, the microamps range of this meter is something Dave Jones was impressed with. Now for higher current. This resistor measures 20.23 ohms. The voltage is now 4.834 volts. The calculated current is 239 milliamps. The meter shows 246.1 milliamps. Please subscribe, like, share, comment, etc. And if you click subscribe, click the bell to receive notifications of future videos.